just want to say welcome everyone in your University of Galway. This room is actually part of St. Anthony's chapel, which was run by the Franciscan monks a long time ago. So it's a pleasure to have you all here. And firstly, I just want to thank Michael and Claire for all their work in organising this workshop. And I want to thank the speakers, Tobias, Juan, Claire, and Daniel, who will be joining us in a few minutes. So thanks very much. So I'm really looking forward to the workshop. My name is Ray Morgan. I know a good few of you. I lecture here in Business Information Systems, just over here. And I'm also a researcher with Bureau. So without further ado, I can hand you over to Claire. Thanks, Claire.
Thank you. Thanks, Lorraine, and thanks everyone for coming here today. We're delighted to see you. The view you have is of our wonderful audience here, so that'll be great for the interactive session. So welcome everyone who's come along. And today I'm here to speak about global open source trends, to give some context to the day of why we're talking about open source and what's been happening in the world of open source for the last little while. So my name is Claire Dillon. I've had a long journey that's taken me here to talk about open source today. I started in the startup ecosystem here in Ireland and moved up into big tech for 14 years, where I was involved in developer communities and working with developers in the island of Ireland. But in 2018, I left Microsoft and I first became aware or started working with open source communities. And my first experience with that was actually an inner source community. And some of you may be familiar with the inner source methodology, but it's essentially using open source methods internally in organizations to create proprietary code and gaining some of that great value. But Inner Source Commons, the community of inner source practitioners, is itself an open source project. So it's kind of learning by doing. And that was how I became involved in some of the organizations that were working around open source program offices, because many of the participants in Inner Source Commons were also in open source program offices. And it was through that work that I began to really understand the potential of open source from an economic and social impact perspective, and started thinking about what did that mean for Ireland, and started asking questions about what was happening around open source in Ireland. And because there was no clear answer, because there was no clear place to go to find out, I, along with some, in fact, others in this room, founded Open Ireland Network, which is a community about trying to raise to bring together the community of open source, folks interested in open source in Ireland, but also change the narrative in Ireland to help people be more aware about the potential opportunities surrounding open source. And actually, as a result of this whole journey, I actually left the private sector at the end of 2022 and began a PhD here in the University of Galway, and I am investigating open collaborative methods, basically inner source, and how that's implemented within organizations. But I also still work with some of those communities that are involved in creating open source program offices in academia. So that's my current role. So just to give you an overview of Open Ireland Network, it's about connecting the ecosystem here in Ireland. It's about creating awareness and showcasing the great work that is happening in Ireland around open source, increasing skills and removing blockers to those involved in the ecosystem. But let's have a look at what is open source. I'm hoping everyone here has a good idea of what open source is. So hands up if you know what open source is in the room here. So that's everyone. So I won't go into belabor the point, but for anyone online or in the future who may not be familiar, it's about open source code is visible to everyone. It's viewable. People can look at it, study it. It can be used and shared. There's a freedom to do that, and it can also be modified, which actually gives an awful lot of benefits to a global ecosystem who's trying to advance the whole area of technology. And of course, it's not just code. Most people who are involved in the open source ecosystem know that there are particular tools associated with the use and creation of open source. There are processes involved in that. There's a culture that comes along with open source technology, a culture of collaboration and openness and transparency that actually is very valuable to everyone, regardless of whether or not you're creating open source code. Indeed, that's a lot of what inner source focuses on. But open source is definitely maturing. So I do presentations about open source quite a lot, and I've often asked people, close your eyes and imagine an open source developer. And fundamentally, you get some picture that emerges that's kind of like this, a kind of a lone developer in a dark room. I put this up once and someone said, yeah, where's the sandals? So there's a kind of an idea of these folks that are volunteers, they're on passion projects, they're doing it alone, in someone's basement, And that it's this idea of almost like a hacker culture, a kind of an informal hacker culture, in terms of how people perceive open source development. But of course, that's all changed in the last few years, because over the last 2 decades or more, basically the world of technology has come to understand more about the economic and social impact potential of open source technology. The idea of the fact that there are so many more commercial open source companies now who are out there making money based on services or many other ways that folks can base their business on open source technology, but still be commercially viable. There's a huge rise in investments from VCs into these types of companies. And there are many industry collaborations that could only happen through open source methods, and we'll hear about some of those today. And so industry in general are really thinking about open source in a completely different way. And there are new policies and regulations that are emerging from across the globe that push us towards open source technology based on the real benefits that they're seeing it from an economic and social perspective. And indeed, the professional approach to the use, the contribution, the creation of open source technology has been happening all along. So it is no longer a kind of a best efforts community volunteer effort. It is now a fundamental underpinning of the entire technology industry, and the way in which we can actually get better at using open source, contributing to open source, creating open source. If we all do that, then we actually are able to advance the entire tech industry, which is very exciting. Of course, in universities, there's been a long history of academic open source contributions. In fact, Linux, one of the most famous open source projects, was created while Linus Torvalds was actually in university. And there are incredibly successful open source communities in academia around things like SciPy or even the language R, but or R, as they would say if you're not from Ireland. But NumPy as well. So there's amazingly popular, huge scientific communities all centering around open source projects. And indeed, these days, open source software forms the basis of many research fields, things like computer vision. There are folks in that area that can't get published without being able to publish the source code, because of course you can't reproduce their efforts unless you have got the source code involved. But even across bioinformatics and environmental science, open source projects form the building blocks that are in place to help these efforts in terms of scientific endeavor. And why is it now that open source is probably gaining more momentum and more recognition in the world? Well, I think there's a number of areas. The first main one, certainly in organizations, is around code reuse. It's around efficiency and productivity. I mean, building software is a complicated endeavor these days. It's a complex endeavor. And it's hard to do. And if you had to start every software project from scratch, we wouldn't get anywhere. So code reuse becomes a fundamental, necessary aspect of building technology today, and open source code gives you a frictionless way to use other people's code, which is so important. And in doing so, it accelerates innovation. It allows you to build on the best of breed that's always out there, and allows that to happen in a faster way. So you don't have to get involved with your procurement department. You don't have to get involved with your legal IP transfer department. If you have a policy that allows you to consume open source, then developers can do that with agency. They can get what they need when they need it. And that's very, very important for accelerated development and productivity. It allows organizations to pool the resources. So when there's a common problem out there, instead of every organization in the world, every researcher in the world solving that problem for themselves, it allows you to pool your efforts so that you do that collaboratively, rising all boats. And that's a really key area that is a piece of value for open source. But it also means shared risk. So if something goes wrong, if there's a security bug found in that software, well, then everyone has an actual reason to get that fixed quicker. And it's been proven more recently, although in the past there might have been a myth that open source might have been less secure because people could see it. These days, perceptions are shifting. And certainly in the corporate world, there's evidence to say people think open source is more secure because it's in the open, because there's more of a reason to get things fixed quickly, whereas some bugs in closed source code maybe linger there forever. You don't know how long it's been there. But in the open source world, there's the motivation to get it fixed by many of the users very, very quickly. And again, I mentioned the social and economic impact. We'll talk about that a little bit more in a little while. But I think also the need for trust. So we all know the arguments and the discussions around the trust in the world is breaking down in everything, in our organizations, in our institutions, in technology. And if technology is going to have or realize its potential for good in the world, for impact in the world, then we have to trust it. And one way to do that is to be able to examine the source code so you can see what's happening. And even if it's not every individual doing that, it means that trusted partners can do that. And certainly when we think about governments and the major technology trends that are out there at the moment, trust informs an important part, and open source helps increase trust by making source code available to people to examine and check to see that it's doing what they think it's doing. So let's look at some of these trends. I'm not going to go into detail on these, but when you look at the tech industry, there are various reports to say that pretty much all of today's software in the world contains some open source. You would be hard pushed to find software that doesn't contain open source. So it's a fundamental building block of today's tech industry. 96% of the world's top 1 million servers run open source software. And that's pretty much a given and a field where open source dominates. And indeed, 90% of all cloud infrastructure runs on open source software. So pretty much it's everywhere in the tech industry. And indeed, I won't go into detail on this, but if you're interested, the Linux Foundation has some research guides which talk about trends in this area. I've actually picked out some of those trends in these slides, which are just from their infographic, which I find interesting. I'll just mention a couple of them here today, but I'll also share my slides with all attendees so you can have a look at these ones, but also the originating research. But you can see from these points, if you can scroll in, and some people in the room here might have to switch, but I'll just call out a few. For example, 90% of organizations surveyed use open source at a moderate, significant, and widespread level. I think it's really interesting. I mentioned earlier about the perception that open source is more secure than closed source software. That's a perception that's now growing. Improved quality, productivity. These are reports that are coming back from industry to say this is why open source is so important. I'll also mention that from a European perspective, there is a lot of focus on social change and the potential impact from that perspective. And also the fact that it's being tied a lot to this emergence of general AI or generative AI. So Gen AI, a lot of folks are calling or acknowledging the fact that if you are getting involved in doing engineering around generative AI, then you're going to be working on open source models. For the most part, those are the ones that are available to develop upon. And because of that, this is causing a new interest in open source as well. It's vital to the future of industry sectors. So this is not just around the tech industry, it's fundamentally across industry, and vertical specific open source projects are becoming popular. There's a lot to do with European public sector, and they're realizing the potential for sharing source code across nations. And indeed, even in specific industry sectors like the financial services, they're talking a lot about how open source development not just increases productivity, but actually this report also talks about it making developers happier and more feeling better about their work as well. So it really gives benefits across the board. In terms of economic impact, there's a really great paper that was just released this year, which talks and tries to establish the actual value of open source. And it talks about the fact that they estimate that the supply side value of open source is about 4.15 billion. That would be the cost to recreate all the software that's currently available in open source code. But actually, in terms of usage, the value is $8.8 trillion. So think about that in terms of economic impact to our broader industry. If firms would need to spend about 3.5 times more on software than they do at the moment if open source software did not exist. And indeed, a European Commission study that was released a number of years ago talked to the point that open source software contributes about between 65 and 95 billion to the EU's GDP. And if we increased our open source contributions in Europe, we would generate a between 0.4 and 0.6% GDP increase, and an additional 600 startups would be created as a result of having access to that latest technology. So all across the board, open source has been proven to provide economic value at a meta level and even at a micro level, like when you're talking about the ability for startups to get started and to be connected to these amazing innovative areas. So also, it's very important to think about that social impact. So alongside the potential positive economic impact at a regional, at an organizational level, and even at an individual level, you have this potential to have a positive social impact at the same time. Who doesn't want that? So the UN talks a lot about how if we're working towards the Sustainable Development Goals, if we're building technology that is going to help solve the biggest world problems at a global level, including giving the accessibility to those people who cannot afford to purchase software, then you want to be talking about doing that in an open source way. And by the way, it's not just that reasoning for being able to use the software everywhere. If we're really going to solve the world's problems, we need to engage developers in the global south. We need to be able to accept contributions from the people whose lives are being impacted by these crises. And so open source gives us a way to do that, a mechanism and a process and the tools by which we can engage the global community of talent to help address these global problems in the world today. And so if you look at the UN's websites around this, digitalpublicgoods.net, you can see that they're very focused on open source software alongside open data, open A models, and open standards that would be best practices to help attain the Sustainable Development Goals. And it's an important part of the approach to us getting to those Sustainable Development Goals. And they talk a lot about why that's important, and I won't go through those points. But for many reasons, open source software is the way to go with developing technology that addresses these Sustainable Development Goals. And for people here in the room today, I know you will be also interested in this idea of open research and why that's important. So open research practices, open source software is an important part of open research and is there in the European Commission's definition of open science and open research, and it's an important part of that. And indeed, it's not just in the European Commission, in the UNESCO's recommendation on open science, in Ireland's national open research plan, in the European Commission recommendations around preservation of scientific information, over in the US in the National Academy of Sciences, Engineering and Medicine. All of these organizations are pushing us towards using open source software for reproducibility, for accessibility, for trust, for responsible software development. This is a global trend that's not going to stop. Indeed, this is a broader discussion from the European Commission about the importance of open source for better European services that enrich society. And indeed, we had Barry Lowry at an event last year where he talked about the fact that in the Irish government, we're also seeking to collaborate more with both other developers in Ireland, but also across the EU to provide better services in Ireland and to maybe share them with the world. So I'll briefly now just go into some of the things about what's happening in Ireland, because again, in some of my discussions across Ireland, there is maybe a lingering perception that somehow we're not as active in the open source scene here in Ireland as other geographies, but that's not the case. So when you actually look at the figures from GitHub's Innovation Graph, which is a new analytical tool that they have just put out, you can see that in Ireland, there's been a huge growth over the last 3 years between 2020 and 2023 in terms of the number of organizations contributing to open source projects, the number of developers contributing to open source development projects. Again, moved from 145,000 to 275,000 folks being associated with the geographic location of Ireland, contributing to GitHub. That's not even a complete view, of course, of everyone that does open source software. But I think the trend here is important in terms of it seeing that there's huge growth in Ireland. And indeed, if you look at some of the figures that they show, and you think about the per capita developer numbers that are actually contributing to open source software, we perform really well relative to the EU, the UK, and the US based on these figures. And indeed, the developer growth in Europe in particular, in terms of folks contributing to open source software, is one of the highest in the world. And if you look at where these collaborations are happening, I think this is really interesting as well. You can see flow of contributions going from Ireland to the US. You can see coming from the US to Ireland. What's particularly interesting is actually the fact that the largest incoming cohort of contributions is coming from the EU into Irish open source projects. So you can see in graphs like this, those collaboration networks happening, and I know we'll hear more about that later, but what open source software gives us is an ability to collaborate with our colleagues near and far, and to bring the people who are interested in solving the world's hardest problems together to do that very quickly and easily and in a frictionless way. So I'll leave now by handing over to some of my colleagues to help, and we need the link from Daniel's presentation as well, but we will move straight on now to hear from some of our other speakers who are going to speak today on some of the other aspects that are particularly of interest to folks in the research community around open source software. So thank you very much for listening. And I'll
So, hi, so first of all, apologies. I was trying to find a place. I didn't find a place. I was doing my best. So well, thank you for this opportunity. Thank you for having me here. Scroll down. So my name is Daniel Izquierdo. I'm one of the co-founders of a small startup in Spain. Well, startup. We've been in the business for 12 years now. We develop analytics, inner source consultancy, and consultancy. I'm part of the Chaos Governing Board, which is a Linux Foundation project. It stands for a Community Health Analytics for Open Source Software. I'm president as well of the Inner Source Foundation. So there are some representatives here. My background is in computer science. I have a PhD in critical software engineering, back in time doing analysis of the Mozilla community. Well, this is my LinkedIn, and you can find me here and there. So happy to have further conversations with you. Okay, so the slides are a bit moving to the right, so I'll say if this works. But basically, the question for today is, what is the value of open source? And then specifically for today's presentation is what is the value? What is the value for universities, right? So why are we doing this? And even more, how can we measure this? So how are we doing impact? Are we having influence in open source communities? Are we having our software used by others or our research? So there are certain ways in open source that we can do it, because data sources and everything is done in public. So that's something that we can gather information from my initial repositories perspective. So if you check this slide, each of the dots that you can see here are developers. So each small pink dot is a developer, and there is a connection between the developer and this thing in the middle. If something happened, basically a commit, a ticket, a pull request, something happened there. So basically there is a contribution. This chart here is representing the CNCF ecosystem plus OpenShift. This is an example with an academic reference that we will share the slides later, of course, on this. And all the things that you can see in the middle, basically, all of this here means collaboration. So let's go to a simple version of this. So this is Kubernetes, okay, by default technology to do deployments on large scale, corporations or universities as well. This is OpenShift, which is a Red Hat open source project. And then we have a bunch of developers producing code in OpenShift, right? We have a bunch of developers producing code in Kubernetes, but there are some of them that are working in both places. So these people are quite important for the community because they are basically connecting both worlds. They have understanding of Kubernetes, they have understanding of OpenShift, right? So they understand how both communities work, they are able to understand each other, they are able to make a connection. And these are quite important people. So those are kind of the MVPs, we can say, for this. And open source is not only about collaboration, as we saw before, all that mess. It's about community. So this is a good example of a community. This is FOSDEM. FOSDEM is one of the biggest open source events in Europe, specifically in Brussels, happening at the beginning of February, the end of the first weekend of February, basically. And most of these people are there in this cold place in February because they want, because this is the only place, and typically the annual meeting, they can see others from the open source communities they are part of. This is a great place to get to know each other, to have an event in person, and this is quite technical. So this is for developers. So this concept of community is quite important in open source, and this is part of the rationale for today's presentation. So then, what is the value for the universities? So I would argue that literally the same, collaboration. Then we can have further discussion later. But in the same case as open source, and this is helping build together, with a common vision and a piece of software for universities, should be something similar, basically. Collaboration helps reduce the cost. Collaboration helps to bring others to the discussion. Collaboration helps to speed up the development. Collaboration helps to make software more sustainable and research at the end of the day. So let's go and go for the case for the university, right? So first of all, we want to build sustainable software for research. Why is this? Because first, we want to increase software quality at some point. Let's say that software sometimes is a second-level citizen in research. And that's a problem because more and more we've seen software is basically eating the world. We can say open source is eating software. And then it happens that in 90%, 98% of the software that we are producing, we are already using open source. So what happens if we are producing really high quality software with really high quality research with really poor software. That's definitely a problem. Whatever results we have in research, can we really trust them? So that's part of the discussion. So it's about building this high quality software and having this sustainable over time, because traceability of results is quite important for research as well. So open source would be, I would argue, is essential for traceability of results. First, we need to show this is the code, this is how we analyze, these are the algorithms. So then you can basically trace back everything. And then open source, I would say, is essential to speed up the development. So if we want to be on time for a certain research, the very existence of open source, maybe you are using certain libraries, scientific libraries from Python, Pandas, and some others. Those are basic pieces of information and tools that you can use. So then you don't need to reinvent the wheel once and again. I don't need to write once and again, algorithms to analyze anything. So an open source is everywhere. This discussion about open source. So there is this discussion about building up sustainable software for research, but then it's this discussion about making research sustainable. So there is this study. This is from 2009, so a bit old, but I didn't find any new. But basically, this is telling in the analysis in the study. In 4 or 5 years, there was an increase of 47% of research costs, and this is more or less split into 50% wage-related costs, basically people, and then the other 50% is basically capital costs, equipment, infrastructure, etc. So software is part of this second capital cost. So the question here is, how can we reduce the cost of some of these areas? So if we want to make research sustainable, open source might be one of those paths that we can go with, basically, we can follow. One of the results or the highlights from this thing is basically the public research organizations, basically research institutes or universities. They are expressing concern about their ability of doing two things: finance, research infrastructure, so basically the second part, and to attract qualified researchers. So the university I come from, basically they have a continuous problem on bringing people because of many reasons. One of those is salaries, basically. So how can we attract more people to the research field or to universities at some point? So open source has been proved as a valuable asset to serve with others, at least from the corporate perspective. So why not in university? So okay, two main thoughts up to now. So open source software to collaboratively produce software, and open source software policy in place more or less to attract and retain talent. Basically, there's this core talent that we can discuss. So then going back to the first discussion, so what does collaboration mean for universities? So really quick guess. Well, we don't see this that very well, but these are some network analysis of different open source organizations and university. So the question here for the audience is where do you think is, or basically who's the network analysis of which university, right? If we go for the analysis itself, I think this is Wikimedia Foundation, Open Infra Foundation, CHAOSS, OpenShift. We'll see an example of Johns Hopkins, which is bottom right, why, unfortunately. And then we have ONF, which is Open Networking Foundation. So in any case, Johns Hopkins Library is quite similar to Wikimedia. What you can see is something really like some people collaborating right in the middle, but then there are several islands of software production, basically. So that means, and this is telling me, well, there are small teams producing software just once, live there, and I don't care, basically, but it's open source because I have to do it open source, right? So that's one of the discussions about making software sustainable. Okay, so how does collaboration look like when compared to others? So this is Wikimedia, and on the right is a Johns Hopkins libraries. So it's both of them are quite similar. So there is like certain collaboration happening in the middle, but there are a lot of isolated projects. So software is produced in an isolated way. There are teams producing software. Basically, they don't talk. There is no collaboration from other departments in the university, even from external people out there in the open source world. If we compare this to, well, by the way, the main reason for this is, first of all, Johns Hopkins I would say is a reflection probably of a Conway's law. This is not specific of Johns Hopkins. This is just to illustrate example. This happens in some of the universities we've been working with. So this is kind of a recurring pattern. In the case of Wikimedia Foundation, is because they are mainly basing their architecture in plugins. So then each of the islands you can see, each of these small people with one person with a couple of repositories or so, it's basically really small plugins that are working in, for the whole Wikimedia ecosystem. So on the left is basically architectural result of this. On the right, probably is more a Conway's law, we can say. Chaos versus Johns Hopkins. Again, so in a pure open source community, this is what collaboration means. So basically, there are people working in different projects. So there is one island that we can see here, there is another island here, there are some islands here, right? But the point is that there are connections between them. So information, the value, the discussions, everything is flowing among the community. This is not happening at the university level. So we can see that there are simply, again, islands. So there is this way of representing information. And then there is this division between knowledge silos. So basically each of these islands is a silo. So whatever is being produced there, it's there. So no one else knows about this. Typically there is a problem as well on findability of software. That's a generic problem in the industry, so not something specific to universities. And then this is another example of Open Infra Foundation with three different projects. But because this is an umbrella of open source projects, there are some cases where you can see that there are two projects that there is no connection because it's no sense in this case. But that happens, so it's not something specific of universities. Okay, so kind of four conclusions I would say with all of you is there is certain isolated development. There are weak connections within university departments, at least from a software perspective. That's all I'm saying. There are knowledge silos, again, from a software perspective. And then it seems that the people that are producing software are small teams. So it's just one person, 5 people, 6 people. But makes sense because the primary activity is to produce research, so papers. We can see at the end patents, maybe depending on the field, not for software, ideally. But then software is used as this second level citizen in the research production. Okay, so basically we think about the business case for open source adoption. We can think of first, produce high quality code for research purposes. So then the higher the code, the more trust we can have on our final research, basically. Of course, it's about not reinventing the wheel, but all of us are using existing tools, either proprietary or open source tools, but we are using existing tools, which is good. With open source, at least we can lower the cost for research. You remember the wages and the capital, we can reduce the capital part. An example here from another source that a customer we had, this was a collaboration between 4 different European countries. So by collaborating, not in an open source way, in this case, it was a proprietary software, but producing a software within the company in a collaborative way. The business case for them was that they were able to reduce by 30% the total cost of the initial investment, that if they were going to produce 4 times basically the same piece of software. So it's not basically fourth of the total cost, but definitely there is a reduction of the total cost if all of the countries are producing code all together, localizing for their own needs. Okay, so this is not a big deal. So basically there is a core part of the source code, then they are localizing for their own peculiarities. Attract and retain talent, which is a problem as in any place in industry or academia. And definitely in the long term, it's not only about producing impactful research, but probably software and having software that is used and transferred to industry. Okay, so these are probably my arguments to say why people should be adopting open source. This is a report from the White House. We cannot read everything, but basically this is telling 2 things. First of all, we need data to make certain objective decisions, basically. And thanks to the open source way of working, which is basically doing everything in the public, openly to everyone, everything is open. We can go there and we can gather information and we can measure stuff. So then we can have those insights and reports that we need to make the right decisions. Okay. I really love this cartoon, but basically it's telling you, well, without data, you're just another person with an opinion, and sometimes our perceptions are wrong when we start, looking at the data and say, okay, well, we are researchers, you are researchers, so then it's like, okay, yeah, one thing is the perception, I need results. Okay, so data is telling you, no, this is wrong. Okay, data is right sometimes. We always have statistics. Yes. Yes, okay. Okay. Okay, so starting the journey to measure open source software at universities. So I would say the business or what the discussion up to now is more like clear. We want to be more effective. We want to be more efficient with funding. We want to attract the right people to be part of our research team. We want to have the top people in our university. So basically, where should I go? How can I start, right? And one of the very first point is, do you have a complete view of the open source that is being produced, for instance, at Calgary University or any other university? The answer typically is no, because people have freedom, they can do whatever they want, they can release open source any place. And that's something, that very first step of gathering and aggregating all that information is kind of a headache. But anyway, that's kind of one of the very first steps. But there are some challenges for all of this journey. So I would summarize them into this. First of all, every researcher doesn't have a computer science background. So we are discussing about producing high quality software. But we may have people coming from maths with no computer science background. So then, what is the role of the university for this specifically? How can we grow these people into producing better software? So open source is probably a good path, because it is kind of forcing you to produce software in a certain way that if this has certain success, it will attract certain people. So you will start producing certain community. And if that's the case, you will start having on the table certain questions. Okay, how can I install the project? How can I read about this? How can I improve this thing? What is the architectural document? So there are some questions that you will have on the table, and probably if you want to grow the project with external contributors, you will have to answer. And that's a challenge. So that's a journey. There are tools that are helping to make this path easier, but there's a process. So this open source way of working is slightly different than just leaving the code in GitHub or GitLab. And this discussion about research produces software as a second level citizen, I think is quite relevant. So we should focus more there, just because research is relying on this type of software, second level citizen. So we should take care of the software if we want to have the final really high quality research. So if we are able to open the software, if we are able to start having contributions, basically we'll have more people looking at our software, we may have contributions, we may start having a community, we may have at the end a research community with certain impact in the future. So that's something to have in mind. So if we go back to the example of universities, okay, should move forward. So first of all, we were discussing who is developing software, open source. See if you can characterize this information, who is doing what, when, and where. So then okay, all of these departments, and it's not for the pleasure of tracking people, it's basically to understand and have an aggregated view of what's going on, and simply keep adding repositories in an iterative way. So, and grow the development team and research. That's quite important. Perhaps from a university perspective, one of the policies that could be addressed is about a growing standard, growing processes, perhaps having common tools that are helpful for everyone, researchers and faculty members. So then this is kind of enriching the whole journey experience. Okay, so if we want to move from a left discussion islands of technology, we can say, into a open source full collaboration model, we can basically, or we would be able to share the cost, to deal with the talent retention and attraction, to remove certain inefficiencies. But first of all, we should all start internally in the university, and probably why not start talking to other universities and research centers and start collaborating. Because if we need a basic model for astrophysics, why not about doing this all together? Then the research will be a different thing. And this is it. So just to illustrate all of this based on personal experience. So I come from a research group at the Universidad Rey Juan Carlos in Madrid called Liversoft. So the research group started in 2000. Is this thing here. In 2006 is when I joined the research group. And then we were doing empirical software engineering. And then in 2012, we decided to found Bitergia. Bitergia is basically taking all this research and say, okay, what if we create a product? We said, okay, sure, let's go with this. So we were testing the market for 3-4 years, up to 2015 approx, we can say. And then we decided, okay, we need a change in the technology. So then we need to modernize this. We need to do, use other tools. But this is where from Metrics Grimoire, which was our small research community that we had certain users from academia, we moved into Grimoire Lab, a more product-oriented for corporations, we can say, as well as universities and others. So then, because we have all of these universities around, open source foundations around us, we were working with Linux Foundation, Mozilla, Eclipse, and some others. Chaos was founded. This is a working group coming from the Linux Foundation, again, community health analytics for open source software. And then that was in 2000, and this brought huge visibility to the project, okay? And then these numbers here, because you cannot see what is on the right side, basically, these are 2019, there was a new project, basically that for Grimoire Lab, and say, okay, we are producing this new service. In 2020, Linux Foundation decided to fork the project and produce what is called Linux Foundation Insights. In 2021, it was the Rochester Institute of Technology that decided to create Mautic, which is based on Grimoire Lab. And 2022, Huawei decided to run OSS Compass, which is a tool to do health analysis based on Grimoire Lab. So the lesson learned here is that basically it took like 12 years to produce research, and then 3-4 years to test the market, and then basically this is 16 years. And then in just 4 years, people that we didn't know were able to produce software based on our research journey, plus testing the market in 4 years. They produced 4 new projects. So this is the beauty, and this is the value of open source. This is how, like this, in 1 year, you can produce software from scratch, right? Based on existing technology and research. And I think this is the power of collaboration, we can say. So how to start gaining insights. This is the last slide, I promise. So if you are an individual, you want to try the technology and everything. So the different charts I showed today are based on Grimoire Lab. So in Bitergia, we have Bitergia Analytics, which is the commercial service, but Grimoire Lab is the open source project. So you can go there, running by yourself. There's a community, so we will help you to try. So you can join the Chaos community. If you're an organization and you want to check what's up there, first of all, they have an official GitHub organization. Just to start with, is there a place where you can ask the other researchers and departments to centralize all this? So you can start building your own infra, insights, and report. And then finally, in the ecosystem side, if you're looking for services or support, there are companies, Bitergia and others, that are serving those. But this is more for me. You don't have time, but you have money. So this is it. Yeah. Thank you for your time.
Thank you so much, Daniel. We really appreciate that you have that unique perspective of being able to bring experience as a researcher, experience as a CIO of a company making money on open source, and also an amazing community contributor. So thank you for coming all the way from Madrid to sharing those insights. We really, really appreciate it.
Wonderful. Thank you so much for that introduction, Claire. I'm really excited to be here with you today. It's really quite a privilege to be speaking to you. And as Claire mentioned, I am a member of the Turingway community, which I will come back to near the end of the talk. But I think today, I'd like to share some of my own reflections, being not only an advocate for open research in the academic community of the past several years, but also as a member of the open source community as well. So, we were thinking about how to add to all of the amazing things that have been said in the meeting today already. So I very much think of my talk as a kind of yes and kind of presentation. And it's also kind of intentionally provocative in a way, with the intention of stimulating, new thinking around what kind of opportunities can we consider when it comes to open source technologies and open research. I want to start very briefly by focusing on the word or the term open research and make kind of a subtle point here. So I consider open research to cover a very wide and diverse array of different research disciplines, right? And a lot of the examples I'd like to share today come from my experience advocating for open science, which I consider to be a very important component of open research, but it's not all of open research, if that makes sense. So there's a subtle difference between the terms, and I just like to delineate the two a little bit, even though most of what I'm talking about today comes from the open science world. Okay, with that said, the structure of my talk today, I think I'd like to start with my reflections on some of the core values of open science, why open science is so important, including in academic research. Very briefly on a lot of the invisible infrastructure of technology that underlies the scientific research that we do. Followed by, I think the biggest part of my talk today is some of the additional motivations for open source technologies to enable open science. And I'd like to bring up the hardware component as well, because we've heard a lot about software. Hardware is another really important component to the conversation. And finally, I will talk about some of the communities that have been so lucky to be a part of over the years that discusses a lot of the things in my talk today. Okay, so open science. I've talked about open science to so many people over the years, and what I have learned is that if you ask 10 people what open science means, they will tell you, yes, I know what it is, but they will give you 10 different answers, right? So I just like to set the scene a little bit for my talk today to establish a common understanding, just to help with the conversation. And one of the initiatives that I've been really privileged to be a part of is the drafting of the UNESCO recommendation on open science that was ratified in 2021. So I had a very small role to play in this, but it was a huge privilege to be part of the process, and it produced an amazing document. It's really long, but I recommend you check it out. And part of it defines open science to mean a set of practices for reproducibility, transparency, sharing, and collaboration from the increased opening of scientific contents, tools, and processes. Again, I think this is an amazing document, but this definition is also quite a mouthful, right? So I tried to reflect on, wait, is there kind of like an essence to this definition? And what I came to is actually the difference between science and alchemy. So what do I mean by this? So I was inspired to think about this by a very provocative digital rights author called Cory Doctorow. And he writes a lot about these kind of fundamental values underlying open research and open science, and indeed open source. And he said, if we think about, how alchemists used to work, superficially, they were running experiments, they had some research questions, they took lots of notes, and they were actually learning along the way. But the thing with alchemists is that they kept what they knew a secret from each other for 500 years. And because of that secrecy, they didn't advance the state of the art very much. And because of that, every single one of them had to learn in the hardest possible way that drinking mercury is a bad idea, right? And I think this really hits at the core of the difference between science and alchemy, because science is a fundamentally iterative process where we are always building on knowledge shared by other people and what came before, right? So in a way, for us to be responsible scientists, we have to continue to share what we have learned with people, with other people, to build on our successes and failures. So I think to do good science is to do open science. And I think that's what open science is really about. Another way to think about this is what I think of as intellectual humility, because I've been an academic researcher for like 15 years now. And reflecting on these years of research, I realized that whatever little bit of knowledge and insight I've added to our collective body of knowledge, I was able to do that because of everything that I've learned from the people, who came before me. So for a researcher, we really didn't get here on our own. It's really built on top of what everyone else has shared with. And it is with all of this in mind that I think, open science really comes with 4 fundamental freedoms, right? And some of you might know where I'm going with this. For any piece of knowledge, it should come with the freedoms for anyone to use it, study it, modify it, and continue to share it with other people, right? To continue that iterative cycle. So this is how I like to think of open science. And so that's the first thing I wanted to cover today. The next thing I wanted to quickly establish is that for this science to happen, we're making use of so much shared technical infrastructure today. I remember many years ago, I was at this hackathon with Arvin Smith from GitHub, and he was the person who gave me that lifetime pro subscription to GitHub that I'm still, getting dividends from to this day, and say, platform that comes with amazing features. But at the same time, I also remember how a couple of years ago, there was this big GitHub outage, right? For a couple of hours. But, it is when things like this happen that we realize how, reliant we have become on the software and hardware infrastructure in our lives, because when they break, when we hurt, that's when we realize, our reliance on these things. And it's important to think about this because it reminds us to reflect on, who gets to have a say in how this infrastructure works and how that infrastructure can work for us as researchers, or just people, who are living out our lives, right? So this invisible infrastructure is really important. And this kind of centralization that's happening, I think, is a challenge that open source technologies can tackle, right? So, I've been thinking about a lot of the motivations for open source, including a lot of the reasons that people have talked about today. And I like to go over some examples. I will talk about hardware examples, but starting with the software one that I think is amazing. It's the Cube Greenland project. So I thought this project is so cool because it started out as a bunch of academic scientists who share a common thing, which is that they all study Greenland. They could be meteorologists, geologists, and a lot of other scientists, right? And they developed this common software platform for analyzing geospatial data, okay, about Greenland. And they built it on top of an open source software called QGIS. It is a geographical information software, so that they can pull all of the geospatial data about Greenland into one place. They have a whole suite of tools built on top of QGIS to analyze that data. So the whole stack is called Cube Greenland. And what happened was that this project became successful, and last year in 2023, they wanted to run a training workshop, for other researchers to learn about how to use Cube Greenland for their scientific research. But one problem they encountered was that if they have 20 scientists in the room coming to this workshop, all with their laptops and their different operating systems and configurations, right? It takes so much time to just get people to the same page to install QGIS, get it running, and then put Cube Greenland on top of it. That takes so much time from the actual training they want to do. So they thought, okay, can we reduce this friction a little bit? And the solution they came up with was that they started with Jupyter Hub, which is kind of like a server-hosted version of the Python-based kind of Jupyter computational notebook that a lot of data scientists use. But they were able to make some additions to Jupyter and tweak it so that instead of just running Python, they're running an entire Linux desktop environment on top of Jupyter Hub. And with that, they can then install QGIS into that Linux environment, and then they put the whole Greenland geospatial data platform on top of that. And once they put all of this together into one package, they serve it from their server so that the participants in the workshop, they can just open up their web browsers, go to a particular URL, and the whole package runs as a web page inside their browser. And this saves so much time in the workshop because they don't need to, set QGIS up on every individual computer. Now, the reason I love this example is that all of these components, they're open source to begin with, and they demonstrate the FAIR principles of open science. Now, I think a lot of you know what FAIR stands for, but just so we're on the same page, FAIR stands for findable, accessible, interoperable, and reusable, right? And this is a big thing in open science, and I think Greenland demonstrates all of it. Because it is open source and published online, it's easy for people to find it. The way they set it up is really accessible. It's interoperable because the components are open source and they were able to treat the components to interact with each other. And of course, it's reusable because other scientists can adapt it to different research contexts. And I think, this is a demonstration of how the FAIR principles that are so important to open science are enabled by open source technologies. Okay, so this is a software example, but if you look at the UNESCO recommendation on open science, it talks about several main pillars of open science, including the usual suspects like open access publications, open data, open educational resources. I think this one is really important. Of course, there's open source software code. In addition to that, the recommendation emphasizes that hardware is a really important part of open science as well. So I like to focus a bit on the open source hardware side of things. And if you really think about it, hardware underpins so much of scientific research, right? It was literally hardware that took people to the moon. That's how much we rely on hardware to do science. It can be huge pieces of equipment like the Large Hadron Collider, or it can be something, seemingly simple, but equally integral to the research infrastructure like microscopes, right, that we use in so many labs today. Now, the thing with hardware is that it's very often closed source, like how a lot of software still is. And some of the challenges with that is that, it's not reproducible in a scientific way. There's vendor lock-in, which was mentioned before. There's forced obsolescence, and there are very high costs, right? And the cost is not only in terms of a very expensive piece of equipment, it's also the very high switching costs, where if you decide there's another equipment you want to use, but since it's not open source, since there's no interoperability, it's very difficult for you to switch to a different platform, for example. And what happens is that this causes a lot of global inequalities in research. I personally know some scientists in some global south countries where they really want to have a particular piece of instrument in their lab, but the one manufacturer that makes it simply do not sell it in their country. And even if they somehow, get access to buy it, the cost is so high that they cannot afford it. And if they somehow scrunch together the money to be able to afford to buy it, once they have it, they won't be able to get any support on it. They cannot maintain it themselves. And it just becomes prohibitively difficult for a lot of researchers in different places around the world. So I think, when it comes to the social impact of our technologies, it's really important to be mindful of a lot of the global inequalities that come with the technologies of today. So in contrast to that, open source hardware is defined as hardware whose design is available, so that anyone, again, can study, modify, distribute, make, and sell hardware based on that design, right? And there are a lot of examples actually in scientific research. An amazing one that I know about is the Open Source Imaging Initiative. So this is a consortium of universities across Europe, including some companies, I believe, who came together to create a completely open source MRI machine for medical scanning and diagnosis. And if you know anything about MRI machines, you know how complicated and intricate they are. And they're actually creating an open source version of it that's becoming successful. Open source hardware has been to space. Researchers in the US, they've developed the ORSAT, which is an open source CubeSat that became a common platform for scientists across the US to build on top of for remote sensing applications. So it's been launched several times already, and I think they have more launches scheduled. But the example that I really love to talk about is the Open Flucturing Microscope. So this is a lab-grade microscope, originally developed by researchers at the University of Bath in UK. I think their team is based in Glasgow now, but the point is, they developed this lab-grade microscope. It's completely open source and modular, and you can 3D print most of the microscope yourself. It comes with a lot of features, starting with the basic ones like bright field imaging or fluorescence imaging, right? But because it is fully open source, there was a separate research team in a different part of the world. They looked at the designs and they actually enhanced it and improved it to greatly increase the resolution for fluorescence imaging. And this is something that people weren't able to do with closed source microscopes that they used before. These are just a couple of features, but what's also really cool is that this open source microscope, if you want to build it yourself, the cost of doing so is only about $200 US. Now, for those of you who have used and bought microscopes for use in the lab before, you will know that these microscopes often cost an order of magnitude more than Open Flucture for doing the same thing. And I think that's absolutely remarkable. And because of its low cost and because it's open source, again, as an example, researchers in several sub-Saharan countries, they were able to take the Open Flucture design to locally produce and maintain that microscope for malaria diagnosis when they weren't able to do it before. And in addition to this, it has actually prompted the formation of some small businesses in those countries to locally produce and sell these microscopes. And it's again becoming a new business model that's enabled by open source technology. Okay, so to kind of build on some of the points made earlier, Joshua Pierce is a researcher in this, and he calculated that open source technologies, including hardware, can provide economic savings of up to 87% compared to functionally equivalent or proprietary tools. Right. And again, my other point is that in addition to the savings, it creates new kinds of businesses. So I have a bit of a background in molecular biology, and I've used PCR machines a lot. And there's a company who sells these Ninja PCR machines for $500 US. Again, if you have bought this for labs before, you'll know that they typically cost an order of magnitude more. So it's amazing how open source not only lower costs, but creates new kinds of businesses as well. Okay, so I talked about some of the benefits of open source technology just now, and to build on Claire's point earlier, I think we're faced with so many global challenges today, right? Whether that's climate change or pandemics or other problems. And they're so big and urgent that I think open source technology is what enables an inclusive and rapid innovation to address these really urgent issues. And to bring it back to my earlier point, I truly believe that we simply don't have time to be alchemists anymore. We cannot afford to be alchemists. And I think this is a huge motivator for why open source is so important and critical to open research. Now, with all of that said, here actually comes what might be the most provocative part of my talk today. So, again, we've seen so many of the benefits and motivators of open source. The collaboration that happens, faster innovation that's so critical to solve problems of today, the lower costs and business opportunities, and so many other benefits, right? But I feel they are just the tip of the iceberg in terms of why open source is so important. And there are some underlying values that I think really adds a lot to the value proposition of open source. And in my view, that could be things like the autonomy and agency that we can have over the technology that we use, and the freedom to use it for our purposes. And I think these are the things that also underpin why open source is so important. Dr. Julieta Avencio is a researcher on open source technologies, and I think she characterizes it really well, where technology really affects the way we think about research questions, right? And, when a piece of technology and the tool that we use is closed source, it means that rather than being enablers of our creativity, we end up doing what the available tech lets us do, right? Because the people behind that technology gets to dictate, what you can do with that technology. And what that means is, in this context, is that closed source technology also implies a certain kind of epistemic power behind it, in terms of what knowledge we are allowed to have and what we can make use of that knowledge for. And some of the risks with closed source technology and some of the challenges for it is that depending on how you wield that epistemic power, unfortunately, sometimes it leads to a kind of intellectual poverty, right? Because only certain people get to have certain pieces of knowledge and not other people. Some people get to make use of that knowledge in certain ways, and other people don't get to do that. So I think, intellectual poverty is an unfortunate side effect that sometimes come from closed source technologies. And this is where the value proposition of open source technology comes in. It's not only convenient and amazing in terms of the collaboration and innovation that happens, there is also an ethical underpinning to it that makes it even more attractive and adds to the value that we already have. And this connects with open research, because open research is not only about publishing open outputs, whether that's open access papers, open data, and open source software or hardware designs. It is also about how we hold that epistemic power together in a more equitable way, right? Such as, those scientists I told you about in South who couldn't do what they wanted to do in their research. And I think this is, in addition to all of the benefits that we talked about, a very important value proposition as well. Okay, so if you think some of these conversations are interesting, I'd like to share with you some of the communities in which these conversations are happening. I'd like to start on the hardware side of things. And over the past few years, I have been very lucky to be part of a group called the Gathering for Open Science Hardware, also known as GOSH. And this is a network of researchers, hundreds of researchers from across the world, literally from every continent, except maybe Antarctica, who come together to think about the important role of open source hardware in scientific research. And we have done a lot of interesting work, such as last year, we created a policy toolkit for UNESCO on the role of open source hardware in scientific research. So it was just published at the end of last year that provides a lot of policy guidance on the national level for research and innovation policy. I mentioned Julieta just now. She is the author of an amazing report called Supporting Open Science Hardware in Academia. This report is geared towards scientific research funders and technology transfer offices in universities to provide some guidance on how universities can enact policies to support people to work on open source technologies in research, and also ways to spin off that development into successful business models around open source, right? So I think this is a remarkable report that I highly recommend you to check out. Okay, so that's the hardware side of things. If you go more broadly than that, I think this is where the Turing Way comes in. So let me tell you a little bit about this community. It started back in 2019, initially as a book, an online book made with Jupyter, by the way, about data science and best practices around how to do data science in an open and reproducible way. Now, it started off as this book, but the founders of the Turing Way, they thought, hey, we are not the only experts here. So can we invite other people to help us co-create this book together? And they started a distributed collaboration process that eventually turned into scientists and researchers from around the world contributing to this book, not only in terms of data science, but other aspects of open science and open source as well. And it's grown into a huge book, hundreds of pages long. And because of how the book brought together scientists from different backgrounds, it's grown into a very vibrant community where a lot of conversations are happening around what open research means, what open science means, and what open source means for this for this work. So we talk about things like what I presented in my talk today. There's also talk about, diverse roles in research, such as the important role of research software engineers in scientific research that's not recognized enough. Or things like localization, so many things about open science and open source are in English right now. But can we translate that to different languages, and what does that mean for people from different backgrounds and kind of social backgrounds as well? With the hope that eventually we can galvanize a cultural shift in terms of how we think about technology and how we think about research, so that again, we can hold this power together in a more equitable way and think of new opportunities for research and innovation. So I think, it's remarkable how over the past 5 years, there has been more than 450 contributors to the Turing Way, not just in terms of pull requests to the repository and added to the book, but also all of the richness that's being brought into the conversations that's being held together by this community. It's a really amazing place, and I highly recommend you check out the Turing Way if you're interested in having these discussions and connecting to other researchers in this space. And I think this really shows how open research and open source can connect to each other in a mutually beneficial way. Okay, so I'm just about running out of time. But before I end, of course, I'd like to thank all of the people who have helped me so much to come here today to share some of these reflections with you. First of all, of course, there's the Turing Way community. Malvika Sharan is one of the co-founders of the Turing Way. We had a lot of interesting discussions on how to make this a more provocative talk. I'd like to thank Lee, our community coordinator in Gosh, for contributing a lot of the thoughts on open source hardware. And of course, to the organizers, including Michael and Claire, for having me here today to share some of these reflections to you. And for all of you for putting up with the last 27 minutes and 50 seconds. Thank you so much. The meta commentary is that this talk is open source and it's published on zenodo.org with DOI. And I encourage you to check it out, fork it, tune into what you like, and visit the Turing Way and Gosh communities where we can continue to have these conversations. So I hope that's kind of helpful and stimulating, and I look forward to learning from all of you. Thank you.
Okay, welcome back, everyone. Sorry we're a few minutes late. We are about to embark upon the second part of this event, and I'm delighted to introduce Tobias, who is here coming all the way from Germany to share some of his insights around the impact of open source on industry collaboration. So, over to you, Tobias. There you go.
Thank you for the kind words, and thank you all for coming. Over the next 20 minutes or so, I would like to give you some insights from the industry perspective about open source, how we experience open source, how we try to collaborate, and what are some of the benefits, but as well the challenges we see in open source. Before getting started, let me give you some info about who I am, who I'm working for, as well as, so that you can get this. Second. Perfect. So I'm working for SAP, which is a software company founded now 50 years ago, and we specialize in enterprise software. We are one of the largest software companies worldwide and the biggest one in Europe, which is kind of cool. And we have around 40,000 developers and a lot of partner companies as well as customers who are building on top of our products. And that becomes important later as well. And we are both developing on-premise software, especially in the past, but now as well a lot of cloud and hybrid software, which is running pretty much everywhere. Just so to give you a sense. Within SAP, I'm part of the open source program office, we are responsible for everything open source related, be it our open source, but as well our inner source strategy. And our main task is to support our development teams in adopting open source, contributing to open source, but as well acting as a kind of steward for any kind of questions, be it from the development teams, but as well from other functions like security or legal and likes. And we as well act as a steward to the outside. So if anyone from the outside, other companies, research institutes, want to reach out and have any questions related to our open source engagement or projects, they can reach out to us and we try to connect them with the right people, and as well we try to spread the word. Lastly, a few words for myself. I'm mostly handling our technical things within the SAP Oslo. I'm a developer, so I love to break things and hopefully rebuild them in a better way afterwards. And yeah, I'm talking about open source and the three levels we see as important to that. And the first one is probably the most obvious one is, hey, consuming open source. We just use it and things. Then I will as well go a bit into the contributing aspect, how you can contribute to open source, what are some of the challenges we see there, and how we try to do things there. Lastly, and which I will focus in at the end on, is how we create our own open source projects, which are our incentives there and what are our intentions when doing them. Let's start off with consuming open source. As we heard already earlier, open source is everywhere and is used everywhere as well. And that's not different for us. We saw internally that nearly every product we are building and every software we are releasing uses open source underneath. Here, just one small library for projects which only add a very thin layer on top of that. And I did run the numbers before the presentation, and we have around 40,000, a bit more open source components which are part of our products. So a lot of open source, which is the baseline of our products. And with that many open source, there comes some challenges. One of the big ones is, hey, how do I know which open source I'm using and where is it used? And that's very important for two main reasons. For one is security. We need to ensure that we know which open source is used where. So if something happens, we can tackle it and know which development teams to reach out and improve the situation. And the second big topic is license. So open source, as you probably all know, is released under specific license, and they come not only with freedoms, but as well with requirements. For example, for attribution, or in case of GPL licenses, as well with redistribution of the changes. And so that's very important to ensure that we know which software we are using there, so we can track that. And two very concrete examples where this was super helpful was with Log4j. It's probably the most prominent example from the last years for this is a super severe severity vulnerability in Log4j. And it was very important to quickly figure out, hey, where is it used, so that we can ensure that it gets either updated or that it's not affected, or that we at least can notify development teams and affected parties quickly. And the second thing, which wasn't that time critical, but had a huge impact as well, is Grafana Labs, which changed their license from a more open license to AGPL, which comes with different restrictions, still open source, but with different restrictions. And that's something where we need to know this information to easier track what kind of where it's used and how we comply with the requirements there best. Open source consumption is great and something which helps a lot, but the really cool thing for the industry and for companies is that you can take open source and adjust it to your needs. So even if you find something that only fits 80% or 90% of your use case, you can add the remaining 10% and get something great out of it without reinventing the wheel. And while this is cool, taking something, adjusting it and using it, the more cool thing about open source is that you can actually contribute these features back, and that's something we try to emphasize as well because it has huge improvements over just consuming it. Contributing back enables or brings two big advantages. It ensures that you give something back to the community, which is nice, but as well ensures that over the long time, the upstream project stays compatible with your own changes. So if you implement a feature on top of an open source project or a small thing which helps it, we try to encourage our development teams to contribute it back to ensure that if an upstream project introduces a bug fix or a security fix or a new feature, that these two things work together and it's an harmonious thing to do. From our, so I mentioned earlier, we have over 30,000 components we are using. While we try to address bugs and feature misses where needed, we have as well some projects where we collaborate more long-term. These are mostly these projects where we have like a strategic incentive. They are foundational to our products. And I brought two examples for that as well, which is Cloud Foundry, which is an runtime, so to say, for our products, which we leverage across our suite. And that's something where we try to actively engage as well as a company becoming active members of the steering board and government board to as well drive the direction to both ensure that the product stays healthy as well as stays in a direction we which fits our needs as well, as well ensuring that others can use it as well. In the second project where we are in a more active contributor role is the OpenJDK, which is the baseline for a Java distribution we are using internally. And all the things we need for this internal Java distribution, we try to contribute back to OpenJDK to ensure that it stays compatible to upstream changes. And so that's the second level contributing. But what is the case if there isn't something which we can use already out of the box? And that comes where the third level, creating own open source projects, come into play. And we have pretty much found that we have three main reasons or incentives for creating own open source projects which haven't existed. The one is probably the most obvious one is we try to solve any technical problem we encounter. Be it like infrastructure management, be it some other things which nobody else yet solved or solved in a way which we can reuse. And that is when we say, okay, we need to solve it, but if there would have existed something, we would have reused it. So when we try to solve that, we then try to open source it and try to get others to collaborate with us and not reinventing the wheel. Because the last thing we want is develop something and then a year later somebody else comes around and says, hey, I have a second problem, I'm trying to solve it as well. And then now we have pretty much two open source projects or two projects which try to achieve the same thing. And that's probably for both parties not the best solution. The second thing, which is more for our benefit, is open source allows for integration. So everything which customers, partners, or other entities need to integrate with our product, we try to open source as well, because it makes it way easier for others to build on top of our products and makes it reduces barriers compared to if we provide SDKs, API clients as proprietary source. One of the challenges there is, which we saw as internally when consuming it from others, is it's super hard to get through legal processes if you have them review some proprietary licenses, if you want to include an SDK into your own product or tool. And having them under a public license like Apache 2, MIT, whatever, makes everybody involved happy because we will go, okay, that's Apache 2, that's fine to use, and we don't need to actually check through the terms one by one, but we can rely on, hey, it's a standard license, you can apply a standard process, it makes the whole process a bit more streamlined. And the last part I want to talk about is projects of public interest, I call them. And that's special projects where the general public has a high interest in getting information about the project, and open source is a great way of sharing that. And I brought two examples for this. One is one from a couple of years ago, the so-called Corona Warn, which was a Corona tracing application funded by the German government with the intention of tracing and notifying people after Corona infection. There was a lot of discussion as well in the public about data privacy and ensuring that such an application can't be used or isn't used to track people individually, but only ensuring that it really is done for notification. And SAP got the job of developing that and as well open sourcing it to ensure that others can review it and ensure that it does what it claims to be. And what I found super interesting is one of the German NGOs, the Chaos Computer Club, actually got reviewed it, and they pretty much said, yeah, we found nothing to complain about, which is already pretty much the highest honor they can give. And so that's something where open source allowed allowed in theory everyone, but of course not everyone reviewed the source code, but it allowed these trusted third parties pretty much to review the source code, give their opinion about it. But, and that I found even more interesting, it allowed communities as well to take the source code and build their own application based on that. For example, we released an iOS and Android app, but for example, the community went ahead and released an F-Droid to the F-Droid App Store as well, an application based on that without our involvement. So that's really cool and helps as well to spread in a good way the adoption of the application. And that's one of the cool. Another cool project, which just started end of last year and has a super short name, is the Important Project of Common European Interest Next Generation Cloud Infrastructure and Services, or IPSys. And that's a project funded by the European Union to strengthen the European digital sovereignty. Aim is pretty much to be able to run cloud services in Europe from independent from others. And what we are doing as part of this project, together with I think 50 other research and as well companies, research institutes and companies, is open sourcing a lot of our own internal infrastructure stack in the hope to get adoption from others, but as well allowing others to reuse it to build their own independent cloud. And I brought 3 examples here, which are projects you can as well already check out if you are interested in that. That's for infrastructure management on a very low level. So you have servers, plug them in. How do you manage that you have 1,000 servers running, for example, which is our Iron Core project. We have Ghana, which we are using extensively internally and have as well adoption from a few other companies and partners, is a Kubernetes as a service solution, similar to, for example, Google Kubernetes Engine, allows you to run your own managed Kubernetes on top of that. And something which we just released as open source shortly before is the Cloud Operators project, which allows you then to manage a fleet of server runtimes. So you have like 100 Kubernetes clusters and you need to deploy applications on top of them across a global scale. Not a problem many people have, but something there, if you have that problem, it's rather hard to get that solved, especially in an open source way. So that's something we are now developing for next. And my last slide is just to quickly summarize the benefits we see of open source collaboration for the industry, and especially from our perspective. And I think 2 of the points we already heard earlier today. It improves development efficiency. It's easier to just take something which is already existing, adjust it to the needs, and reinventing the wheel completely from scratch. The second point, which goes into the same topic, is it's better to have something already existing and building on top of it than just building the whole stack on your own. And that's where it's better to come together, solve common problems, and then focus on the things which actually add value on top of that. And one thing which is new and I haven't heard yet is open source allows for a more standard collaboration model, with having standard licenses in place, having standard methods on how you can interact with each other in place, makes it a lot easier to collaborating with partners, but as well with other people, instead of having in a company set up, having to go through your legal department to declare an official partnership or development process with somebody else. And it allows you as well to collaborate with anybody or more or less anyone, even if they might be otherwise your commercial competitor. It allows you to solve the same technical challenges, which wouldn't happen if you need to have like an official partnership with them, which probably wouldn't happen. And I think I rushed way too quickly through the presentation because I'm already at the end. But yeah, thank you very much for your attention. I hope you could learn something, and I'm handing back to Claire.
So I suppose we'll kick off by first of all saying to everyone in the room and everyone online, if you have a question for one of our panelists, if you've been storing it up, will be able to take questions from the online audience, so you can stick those in chat. And if you're part of the online audience, please do that. And would anyone in the room like to get us kicked off with a question that you might be storing up from earlier? Because if not, we'll start off. So I'm here. We heard a lot today about so many trends in open source in terms of what's happening at a global perspective. We heard about its relationship to open research and open science. We heard about it used in industry collaborations. We heard about the aspects in terms of how universities are currently doing open source. And I know, Ian, we've had a lot of discussions about how this fits with overall IP policy and general technology translation and impact for research. So I'm going to start by asking everyone on the panel to consider, when we think about all that and we think about the changes that have happened over the last few decades, how should universities react to that? Because I think there are some things that are embedded in a university system that perhaps can help, and some things that perhaps are inhibiting universities' ability to get the most out of open source and to get the most impact from open source. So I just want to hear from everyone on the panel to say, what do you think should be done to, I suppose, enhance universities' opportunity around open source? So I'll start with you, Pen. Let's go down the line. Yeah, sorry, now that was 5, was it? But
Yeah, so I think I like to use this to pitch a concept that I'm working with my colleagues on as part of a research project at the University of Bristol right now. So as part of my postdoctoral research, we are looking at, not only open source, but open research in general. And what are the facilitators and barriers towards adopting these open research practices, right, in universities? Now, it might not come as a surprise to a lot of you, but the way academic institutions are set up right now, it does create certain barriers to doing more open research, including sharing open source technology. So we are actually engaging with university decision makers, for example, with people in research and innovation services, to have these conversations to characterize what these barriers are and how we can improve universities' policies to enable more open research. Now, I say all of this because we call the kind of research that we do meta research, or research on research, right? Because we're doing research on how research is done. And I think it will be very good for universities and research funders to realize that there's a need for doing this kind of research so that we can more formally study what these barriers and opportunities are, to create the evidence base to inform policy changes, if that makes sense. So I think this is a gap that's worth filling, so that we can make very informed decisions when it comes to enabling more open source practices.
Brilliant.
If that makes sense.
It does, I'm very meta. We really appreciate that. No, thank you, Ken. And that kind of discussion, I think, is happening globally.
Mm.
As the world realizes that, you know, the whole university sector is similar to how the corporate sector have actually been thinking about things like DevOps and just getting better at actually producing the infrastructure for everyone to get more productive. I think in general, universities are probably thinking about similar type of challenges, but also those policies and processes, as you say, that can sometimes block or enable. So thank you for that. So Tobias, from your perspective, thinking maybe about the industry collaborations, what can universities do more of? What should they perhaps do less of?
I do think what's one topic which is super important is trying to aligning both a bit more on the same tooling set.
Okay.
What I have seen from my own studies is that if you are in the research and the university, you sometimes work with completely different tools when being in the industry. And I do think that open source allows here to use the same tooling in both, because sometimes there are restrictions on which you can use in the industry. Sometimes there are restrictions which you can use in the university. Be it budget reasons, be it license reasons. But I do think that open source allows a good middle ground of having the same tooling or the same common ground, allowing as well then for easier collaboration down the road between the two sides of.
Excellent point. And I suppose, I mean, one of the things that open source allows for, as you just pointed out, is just to see what that is. I mean, you know, it's something that can be established ahead of the time before industry collaborations can actually happen, to see how that ecosystem is working and what they're using. It doesn't require a discovery phase, because well, maybe it does still require a discovery phase, but presumably that's something that is in the open, so people can more easily discover what that kind of standard tools are for a given ecosystem.
And it then allows the both ecosystem industry as well as universities to easier collaborate together if they have a common ground, pretty much a common tooling. And I think that's an important thing to have, because if you first need to invest a lot of resources on both sides in having the same tooling, having the same collaboration methods, it makes it way harder to collaborate compared to having like these standards already in place beforehand. And it as well helps both parties improving these standards together.
And in your role as being part of the corporate open source community in Europe, would you see differences in that tooling across various different industry verticals, or do you feel like the corporate world in general seem to, you know, coalesce on one more common set of tooling, or are there actual differences between the industries?
I do think there are differences in the industry, but I don't have a concrete example now at the top of my head.
So it's important to do it in context, basically, in terms of for whom, when you're thinking about who you want to collaborate with, it's important to understand what they're, not necessarily assume their tooling either. You probably just want to actually collaborate with them.
Talk to people, ensuring that you have at least the same understanding and not just assuming that everybody else does it the same way as you do. But when you have this understanding, trying to talk together to find maybe what's the way to collaborate together, or what's the tooling required to collaborate together. And I do think that open source allows there to establish this common ground.
Very good, thank you. So Daniel, from your perspective, thinking about, well, I suppose thinking about it from all the hats you wear, as a researcher in the past, as a company who is working in the ecosystem, as a collaborator in the open source community, how are you thinking that the whole university sector can, like, what should they keep doing? What should they stop doing? What should they start doing?
Yeah, I think so. Part of the discussion probably is at two different levels. So if we think about researchers and faculty members, typically they have enough freedom to do and use and produce whatever they want. It's always aligned with their research and so on. From a tool and process perspective, we are much better now with tools and that are kind of getting the whole process more homogeneous, and with good practices as GitHub or GitLab. So all of this is publicly available. So it's, I want to free this as open source. Then there are some places by default that you can use. So then I would say that researchers at that level have a certain freedom. I think the missing gap probably is from a more university perspective, administrative or so. At that level, there should be some frameworks on how to proceed, how to grow the people, how to specifically train researchers on, yeah, but part of the discussion I was sharing before, right, of being better software producers, engaging better with the community, and perhaps some strategies to do certain community building if you want to. So this is not mandatory, but then just with the purpose of building certain more sustainable software and sustainable research over the years, that's probably some things to have in mind. This does not mean that everything has to follow the same process and have a really awesome community. That's not going to happen. But there are some times where this makes sense. And then how to frame the basement with collaboration with the industry, with other universities, and so that's something that should happen at some point. Are we recording this? Well,
Yes, we are. We're on the record.
so just personal experience. One of the from the university I came from, and we started. We tried to bring the university to be a shareholder in the company. We didn't find a way. So I mean, it's true. This was 12 years ago, but because of this experience I had, is how can we do this? At least in Spain, which is my experience specifically. I don't know if this is something that is happening, for instance, here in Galway or Ireland, but then give you the next.
Well, that's a nice segue into the discussion about the involvement of universities from a commercialization perspective. And given the rise of so many commercial open source companies now, given the increase of VC interest in open source, companies that are reliant on open source software. Ian, can you maybe discuss with us some of your thoughts around how universities should respond to that trend and indeed the challenge that Daniel faced?
I get the easy question.
Yeah, and also because we haven't heard yet from you, maybe give some background as well to your own role here, just because just to give people context as well.
So I work in the innovation office here, which is the technology transfer function for the University of Galway. I'm a case manager in the ICT sector. My background is in hardware and software development. I've been in the role here for about 7-8 years, but before that I was started as a chip designer, software designer, software project manager. I was in a startup. So I've kind of seen life from both sides now. So as I was listening to my co-panelists here, I was, Penn introduced his talk by saying yes and I'm here basically saying yes and. I work at the interface between the university and the external actors who have different perspectives and different needs. So I might make one summative statement, which is with regard to, 3 words popped into my head: cost, consistency, and coherency. So I think each university, and I'll generalize this and look at Penn, probably does excellence in spots. And probably does very good everywhere, but excellence in spots. But if you were to ask the university, 1, you couldn't find anybody to ask, and 2, they wouldn't know how good they are. So part of what I can, and I hate to use the word monetize, but what I can represent to the external communities are that sense of the university as a coherently, consistently good actor with regard to software development, cognizant of its role in the open source community and all that entails, cognizant of how open source opens routes to either monetization if you want, but primarily deep and meaningful collaborations based on Tobias's point. So to me, I am the pathway by which the university delivers impact, not monetization per se. If there's money, great. But primarily around how this university delivers on its mission, delivers on its values. And open source would seem to be such an obvious way to do it. The challenge for us is to understand how to use it correctly.
And thinking about the University of Galway specific context, and I'm curious because Daniel posed that challenge of, if there was a spin out, from the University of Galway based on open source software in some way, does the University of Galway have a mechanism to get involved in organizations like that spun out?
So at our stage of maturity, the university takes a minority shareholding. So it's the difference between a minority shareholding and all that entails and stepping up, which is active participation. So the university is taking the view that companies know best how to determine their future. So the best we do is say we license in enabling technologies. For an open source case, we find ourselves licensing in the additive bespoke software based on an open source underlying open source components. How active we want to be, I don't think we've had an opportunity where the university would have, say, ownership over an open source project and is actively engaged in ensuring that open source project through the spin-out company gets to a different place. So it's a bit like Tobias's point. If you swap out SAP and university, SAP are interested in active contribution so that the retained or the core application is heading in the right direction, driven by subsequent companies' interventions or developments. We're not at that stage yet. We have one or two open source projects that we think need to go in that direction, but we've yet to sort of fully comprehend what that means, because it's more than just passively expecting it's going to happen. There's an active component, and this university hasn't yet got to the point where it actively works with its spin-outs.
Thank you, Ian. And we have a question from the floor.
It's a comment.
A comment from the floor.
I'm gonna suggest that in your head and in your discourse within this university and with other universities, that you substitute stewardship for the word ownership. Because stewardship is the proper role of universities in projects that have been spun out. That's where you create a comfortable umbrella. You get halo for having done that, and in some cases, you get additional grad students who applied, you get maybe grants from companies who are interested in the work that you've helped create and want to way, a tidy way to be involved with that also gives them a minority share, right? But this idea of ownership is part of what's in the way. If you think of it as stewardship, I think you'll find it's an easier road.
So I think we could take
So
that.
just before you come back, just because some people may not have heard that online, I'll just repeat some of these comments. So this was a discussion about the terminology we use and how sometimes the words we use matter. And in this case, it was a suggestion that perhaps the university's role should be that of a steward, and that the stewardship of projects may be may produce more fruitful conversations than the term ownership. Back to you.
So I think stewardship is the correct term to be used throughout.
Yeah.
Be it data, regardless. So we get to establish any monetization path based on an open source project. So it's unexplored territory. But I think there are challenges around the opens. And I was looking forward to the distinction between open science, open research, open data. But I think stewardship, is more coherent with the university's role and values. So if I inadvertently use the word ownership, mea culpa. But I think stewardship is when the university achieves that systemic view or that coherent view as to how it approaches its opens, then I think stewardship is the framing of whatever we do. It will be framed with regard to we are only stewards for this as it passes from and through us.
Very nice. So I think there has been a general consensus that we like the word stewardship. So for all the opens, which I really like too. And I want to build on that theme just from my own perspective. If I was thinking about what I would love to see from the university sector, I think it's more discussions like this. I think there is a lot of conversation to be had about the context of open source within universities, how that differs from both what's happening in the corporate sector, but also in the broader open source community. When we think about the constraints that exist within the university's, system and the broader research system, and how that might impact people's goals or tools or infrastructure or anything, the process that we all face. I do think that having conversations like this, where we talk not just about what's currently happening, but the kind of words and language that can be most impactful, that can be very, very valuable. So thanks again for everyone having this conversation. So I'll open up again to the floor. So does anyone have a question or a suggestion or a comment based on this discussion about what you think universities need to consider or aspects we need to consider in universities to support and make open source a more valuable part of the opens as well, and in terms of getting impact for the university? We've got a question over here. Eva?
Can I ask if you think the university is the right level to be approaching this at, or do we need to go higher and look at policy or funders or the drivers of change in this area? I mean, I think you can have bottom up and that's fine, but you also, for a lot of universities to implement policy or change, it needs to come from top down. And if so, how best can we influence that, or what are the four?
Great question. So again, to repeat for those online, so the question is whether or not we're thinking about it in terms of where the kind of influence needs to come from. Is there a potential for a policy, higher level policy discussion that could influence universities' actions? And if so, you know, what might that look like, if I paraphrase that correctly? So does anyone want to take that one?
I can
Ben, yeah,
try
go
to
first.
take it. So because of some of the meta research that I'm doing right now, one conversation I had was actually with one of my PhD supervisors, who after I graduated and got my PhD, he not only became department head, he also held some decision-making roles in the university. And I had a great conversation with him where we were talking about exactly your question. And he said, you know, when he sat in that position, making university level policy, he realized that even within the institutional constraints that universities operate under, he discovered that there is still a lot that university can initiate on their own. And we had a whole conversation about things to discover that, hey, actually within the university, we just need to decide to do it. No one's actually stopping us. On the other hand, those wider external constraints do exist. Again, using my example about the need to do more formal research on our research culture and how to enable open research. On a higher level, UKRI, which stands for UK Research Innovation, the main public funding body in the UK, just very recently, they pre-announced, and I like to pre-announce, they like announcing the announcement, that they're gonna have a new funding call, I think in late April, for meta research projects that's cross disciplines. And this description of the call is specifically to ask for researchers to do research on how can we improve our research policies and institutions to improve our research culture, such as to encourage more open research. And I think this is also really important on the national level. When a national kind of public funding body recognizes this through the funding incentives that they have, it really directs, you know, people to do the work that I think is needed to create that research culture and institutions to enable open source and open research work. So I think it really comes from both ways. And I think this is a conversation that needs to happen between universities and higher level policymakers to see how we can create those incentive structures. If that makes sense.
Yes, thank you. And I would like to just build on that as well, just to comment about the fact that I think, as you say, first of all, you know, people follow the money. So like, you know, so if there are changes in funding policies, that you know, is a clear incentive for folks to change their behavior in order to access that funding. And that's absolutely the case. And it's no doubt that higher level policy changes do influence or send signals as to where things are going and the motivation, and help give clarity around why we might be moving in a particular area. I'll just add a note of caution to say that certainly in the public sector space, and when we think about governmental policies around open source, that there was a lot of attention maybe 10 years ago given to the idea of, oh, we just need government policies. If we have a government policy, all will be okay. And some countries did bring in government policies to suggest that they would have more open source, but it didn't necessarily solve the problem. And so I would just put a note of caution to say that, yes, it would be wonderful to have more high level policy direction and funding and everything, but there's still a job of work to be done to make sure that if that policy exists, that it's a frictionless path to enabling that within the university sector. So back to your point, Pen, there's lots that universities can do, and there's lots that needs to be done to actually make sure that even if there's a policy change and everyone says, yes, from here forth, everything should be open source, to get that embedded in the system of university and the individual behavior of researchers so they understand what that means. You know, that would be a huge job of work regardless. So I just, you know, it's no easy answer, I guess, but just to point that out. I'm sorry.
Yeah, and sorry, it was just to build on a question or build on a point that Penn had said, and I'm more curious than anything else, is you talked about the constraints
Mhm.
that exist, and I think it's fascinating to understand what those constraints are on the basis that open source came out of the university, right? So the foundation of open source has come out of the university model. It's gone out and effectively brought this, wonderfulness to the world. So, as it evolves now, and again, at a rapid pace of adoption right now, I suppose the university's role there is again becoming even more important. And I suppose what constraints do you see in order for those adoption practices to come into play, or that it can become again more widespread, accepted, or is it not? Is the question.
So just to repeat the question,
Yeah.
that's online, the question is around what are the constraints that are actually blocking this within the context of university? So we'll get some examples then.
So an open source example comes to mind, actually, and without naming too many names, obviously 3D printing is a big thing now. It's really well established, actually, and it's built on top of a lot of previous technologies, right? And there's this researcher an engineer who developed one of the key technologies underlying 3D printing today. He worked at a university and he did all of the development there. But he published his work, he created a community around it that's open source and all that. It's so great. But within the university, when people in management learned of it, they're like, oh wait, you didn't patent this, you didn't commercialize this, there's no spin-out company from this. Your thing is obviously, not of value or something that we care about. And he was sort of discouraged by that. And he left the university because of that. And to tie it into the conversation I had that I was talking about before, what happens is that even within a university, some of the constraints are simply because a lot of the open research and open source work is not recognized and not incentivized, such as in internal assessment structures or promotion assessments, because academic researchers are so short on time, and if they're not going to be recognized or assessed for doing X, and they are only assessed for doing Y, they only have so little time, so they have to do Y instead. So, for example, being able to realize that hey, there's actually more we can do even within a university. One thing that I know is happening at the University of Bristol right now is that I was part of a small part of a effort last year to review and revise its internal assessment framework for academics, and now there is a lot more recognition of open research and open science and open source work by academics in the promotion structure within the university. And this is something the university can just decide to do, even without having to change the wider higher education sector and all of the other external institutions to make happen, if that makes sense. So I hope this is an example of how universities can make some changes internally to change the incentive and recognition structure to recognize the role that people play in open source and open research.
Thank you very much, Pen. And we've got a comment from the floor.
Yeah, so another comment. There are some schools that were famous for their openness for decades that recently changed that stance in favor of doubling down on patents. And taking on patent reform is such a big problem that nobody really has time or energy to deal with it, and yet it's got to happen because those structures don't actually map very well to the life of software, the value of software, lots of things it doesn't map well to. But every time we have a single example like a CRISPR, right, that where two major universities end up duking it out and one of them wins and one of them loses, who really loses in that are people that are trying to work transparently without pandering to patents. I think that because all of the universities that signed on to the patent thing are like A-list, Harvard, MIT, Stanford, That feels overwhelming to smaller universities that aren't as well funded, but actually the smaller universities have a much bigger role to play than they think they do. There's nothing that says that those people made the right choice when they totaled down. And at least two of them, fought it out, and one of them sad that they didn't win now. What would be great is if smaller universities, like everything in Ireland, would decide that they could go another way and go ahead and build that value and let those people learn their lesson on their own. I think that would be really valuable. But one of the things that means is that people that support researchers who are doing open source have to have access to legal support. And if it's too big an ask for individual universities to provide that support, then SFI or somebody like it should be creating a board of people that all the universities could use for that purpose. Because I get calls, and I am not a lawyer. I did run the open source initiative for a long time, so I know a lot more about licensing than most people. But there's no way that I can go up against MIT and say, you guys screwed this up. But a consortium of universities could.
So that's probably a long comment to summarize, so I hope some people online heard that. But what I will say is that it was a call about the idea that just because some big name universities might go in a way that suggests that they're moving in a less open way, it actually provides an opportunity for less big organizations or universities to actually show the way, show value, and actually compete in that academic landscape based on an alternative approach, which of course is exactly what's happened in the commercial world. So yeah, absolutely, that will follow a pattern that's worked in elsewhere. Aoife.
Can I just add to that? I think one of the challenges is that the means by which value from open is captured is really challenging still. Patents are a really easy metric. Like you can count them, you can count the number of publications, you can do all that, but actually capturing different forms of value that come from open is a lot more challenging, and often it can be a narrative or a qualitative rather than a quantitative metric, and just inherently they take longer to describe and all of that kind of stuff. So I do think that, and I know there is a piece of work being done on it in certain areas, but it is a piece of work that needs to be done, and until you can demonstrate to the powers that be, whoever they may be, are they funders, is it the university itself, whoever it is, until you can like show and demonstrate that value really clearly in a way that they understand, it's always going to be a challenge fighting against, well, we have however many 100 patents here. So you need some sort of comparator, and I think that is still a gap.
Okay, thank you. And again, to summarize, that's a call for some way of demonstrating the value of open collaboration when put up against how easy it is to just count patents. So really this is about how do we tell that narrative, how do we prove value, how do we compare levels of value and things like that, in terms of being able to do that easily, to describe it to the powers that be.
Just one,
okay,
sorry, first.
And I think, I always harp on about this, the definition of value, right? So when we define what value is, well, then we can match what it turns out to be. And what I'm hearing is that, commercialization is a significant value point, but again, how we capture all the other value points and how they align to university goals. And I think that's important. And how do we look at, again, funders who are taxpayers, our value as well into this whole world as well, and how does that get included?
Okay, so the question is about value. So I'll just, before we go back to I do want to come to some of the panelists here. Ian, do you have a comment to make about capturing the value? And then we'll come to Denise as well, but just to follow up on that point.
Denise was after.
Yeah, then you go ahead, go first.
Because we'll hear you.
Also, I'm gonna talk too long, so.
I think there's a hierarchy of problems here. You could start it off with regard to, the external ones and how we manage all that. But I think from Penn's, Daniels and Tobias's talks, there's a set of capabilities you can just get on with. And that just improves operational efficiency and code reuse efficiency. If you only do the inner source versus outer source model, that's fair enough. So I think there are challenges and means to address those challenges that are entirely within our organization. And that can start with just the basics, software engineering basics at the ground level, working up through some organizational constructs that resolve this conflict between motivational factors and drivers. And then there'll be external, funder-driven valuation metrics. Patents is a easy valuation metric. Not saying it's a good one, it's an easy one. So there's certain valuation metrics that are just easy to point to. They're not easy to achieve, but they're just commonly used. And the whole impact narrative, the impact story, that is going to have to evolve and develop over time. But I think just not to lose sight of the fact that there is a hierarchy of problems. So what problem do we wish to solve today? And I think there is value and merit in just delineating that which we can and should do now, which is achievable by the talent within schools, that which is achievable and doable across the institution with regard to reward mechanisms, and that which needs to be addressed at a higher level, meta level perhaps, in funder. So just not to lose sight of the fact that it's not one problem, it's a hierarchy of problems here.
It's a great point. Perhaps we need to do more work to delineate those so we can all feel like there's something we can all go after immediately. Daniel?
But to add to this point, what I would say is that thanks to open source, or open source is kind of lowering the barriers. All of these hierarchical problems, and then it's helping to move forward probably faster and fail faster.
Yes, it's the mechanism by which you get there quicker.
Yeah.
Because rather than saying, let's duke it out over who's got the better algorithm to do X, we just work in the open source domain and work through the open source as a way of enabling all of us to come to an agreed position and an agreed way of working and an agreed repo and all of the things we have to do to be good citizens in this space.
And do you want to come back?
Yeah, I do. Every time we get into this particular part of the conversation, I wonder how widely known the Santa Cruz story is. Had you guys just, I know Daniel knows, the University of California, Santa Cruz has an institute that is a profit center for the university, and it's all based on open source. And it's very well documented exactly what they did, exactly how they did it. One of the components is you need local tech or local deep pocket, but ideally tech, to create the feedback loop that makes that work. But I think probably you guys don't know about it at all. Is that true? Yeah, see, I think we have to amplify the people who have figured it out
Yeah.
and threaded the needle.
Yeah.
And then everybody can try to see if it works for them. I mean, there are unique things about Santa Cruz that might not make it work everywhere, but.
So just as, again, just for folks that may not have heard that, and this is a point that not only should we be delineating between these various different challenges, but also there are some patterns that exist out there today where people have actually demonstrated real value and measurable value in the context of open. And the example that was used was UC Santa Cruz, University of California, Santa Cruz, who have a research center that has become a profit center, all based on open source and based on the principles of open. And how they've managed to do that, thanks to a successful graduate who went out and based his whole career on open source, made his money on the back of that, came back and wanted to get the university to enable other people to do the same thing. That proved to be a really great model for the university in terms of actually building this research center based on that technology, but also for all the surrounding ecosystem companies that feed from a talent perspective of that university. So it was a wonderful symbiotic system, all based on open source, that did provide real measurable value. So a good point is we should be capturing these examples as we go of where value does exist, so that perhaps we can start sharing different patterns that might work in that respect. So where would we capture said story is a good point, because is there a place where this meta discussion is happening where we are all contributing these kinds of stories? Actually, I'll ask you, Pen, where should we share that story to actually make that more impactful?
Yeah, well, I was just thinking, this sounds like an amazing meta research project, right? To do a review and explore and see what good examples are out there. It's almost like, the equivalent of doing a very formal literature review.
Yeah.
Rather than finding papers, you go out and look for these stories. And this itself can be an academic research project. And once you've done that, another recent conversation I had was about there's this gap between academic research that happens and the people who makes the decisions. Or the people who makes decisions are not usually the people who will go out and read these academic papers in journals. So how do you bridge this gap is another thing. And one of the leads in our research group right now, he's the pro vice chancellor of research culture at her university. And I was having a conversation with him, and he was talking about how it would be good to have a repository of meta research on, improving research policy and culture that becomes well known enough that policymakers can just refer to. Now, I don't know if such a thing exists yet, but it does remind me of some of the work that the people behind the UNESCO recommendation on open science are doing, because they do go through this process of trying to gather experiences and stories from around the world, in this case, to put into some of their policy guidance. So UNESCO might be a place, I don't know, but yeah, I think there's a place for research evidence on this to be gathered and be visible to policymakers.
And thank you, and I guess that's an action we can take from this discussion. We have a.
Yeah, I have a question about like the role of competition. Like universities have a lot of competition among themselves. So I think that they have rankings and all those things. So all these things have an impact on collaboration. So a lot of people like try to compete. So then I think it becomes like very difficult for people to collaborate in terms of, because the university want to get a good ranking. So I think it has an external role, in terms of playing the universities. Like, how do you think you can address that?
Okay, so a very specific question that I repeat about the idea of competition culture between universities in terms of them wanting to get a higher ranking or whatever. And how does that act as a constraint, and how do you address that in trying to get universities to collaborate? And I need to address it.
That happens in industry. I mean, you have in any open source foundation competitors that are producing the basics of the technology. And then at the end, at the top of the pyramid, they are producing the added business value for their customers. This is working for IBM, for Meta, for Google, so why not for universities? Basically, you can build together all across the universities internally or with other partners, industrial partners as well, the basics of infrastructure that you need from a research perspective. And then go to the top level, and then your research specifically will be very specific for your needs. But the basics you need, open source.
Yeah, I'm actually looking about some research, like people are like Harvard or the top universities are actually doing some fake science, they're actually published papers which were actually flawed. So they actually found all these things, because, they have these incentives, to publish papers. So that's why they need to find something interesting. So even though it was not interesting, they had to fake it. And then they found it was actually not true. So because people are all building this fake science, instead of because of monetization things. So I guess I'm just wondering about the collaboration rules, in terms of in case we try to make this less competitive, maybe people will be faithful, instead of
Yeah, well, indeed, the open source, the transparency would possibly make that one. I suppose I just want to add in, and there's an element to those industry collaborations and this idea of people collaborating on some of the common challenges across. There's a kind of an element as well about the relationships that are formed in doing that mean that there's a added value, and maybe not something that can be measured easily. But if you're in with the cool kids doing the cool research on the common elements versus out on your own trying to replicate it all by yourself, there is a culture where you can start ranking your ability to be in that club as being something that sets you apart from some universities who are sitting in their little island, as demonstrated with Daniel's diagrams, where they're only talking to each other because, God knows the individuals within universities are always looking for those opportunities. They're not necessarily tied to one university for their entire career either. So the individuals involved may have different motivations than perhaps even the institutions to have those collaborations happen.
And before all the hands that were raised just to finish here, I would add that collaboration is already happening in research, because workshops are for that. Places where we go, we try to publish, and then we have discussions and conversations, or this is useful, this is not. And then there is a research process, right? Okay, then I go to a conference, maybe I finish in a journal. So there is a whole collaboration process, specifically workshops in academia is hard for this. Yeah, you are competing with others, but it's for collaboration.
So another point.
It's less of a question, more of a comment, but I think it's interesting because it could be another constraint that we see. Interesting enough, the University of Utrecht, who's like in the top 50 in Europe in terms of contributions, has now decided to pull the plug. It's not going to play the ranking scale anymore. So as well too.
Okay,
So
we've got.
Are there constraints in relation to this, and is it preventing them doing good citizenship? Be interesting.
Well, so the comment is, and just to reiterate here, so what we're seeing is that some universities are deciding to break the mold, try a new pathway, stop thinking about how they've been ranked based on criteria in the past and move forward in what they consider to be the best pathway forward. So maybe there's a revolutionary moment at hand in terms of actually, one would argue that the whole open research, open science movement itself is a change and a shift in behaviour that is moving us more towards that collaborative aspect. So very quickly now, because we're running out of time.
Yes, ma'am. So good news on the patent pool problem in the States. There are two major universities and they're two of the best funded research institutions that refused to sign on to the patent thing. One was Johns Hopkins and the other one was CMU. And I think it's going to be very interesting over the next 10 years, how much ground they gain for making that decision. I think we have to all support them in that. That's the first thing. And then the second thing is a call out. The way that we made open source survive was a combination of strategic humility. We were weirdos and we stayed under the radar long enough until there was enough value creation that we could come out. That, so that was a strategy. But then the other one was when we saw misbehavior, we called it out. And there's probably an unwritten rule in academia that you don't do that, but that is fair in open source. I'm just saying.
So there's more. So again, to summarize, we won't go into the detail, but one thing would be to amplify the organizations and the universities who are either bucking the trend or deciding to go in that more collaborative way. So alongside capturing the stories, we probably need to think as a community about celebrating the stories and amplifying the stories where things are done in what we see to be the right way, but also to have a considered while humble opinion about where people are doing it the wrong way and to be open about that and call it. I think hopefully it summarizes those points. And Kevin, you want to make
I think one problem is perhaps wrong metrics in academia, right? So some metrics of success relate to journal impact factor or university rankings and stuff like that, which counter the idea of, say, the DORA agreement or the open source movement. And so there's that comment. And then the idea that, say, it is easy to show the success or the metrics for patents. I'm just wondering, is that because there's a monetary value you can attach to that? And it was great to hear about that Santa Cruz example where there is value being created in terms of money again, isn't it? But there's other metrics of success and impacts in open source. And I think you mentioned 4 projects or spun out of one open source project, wasn't it? Like you release some open source software and then 4 new initiatives started. Like that's impact. Maybe you don't measure it in euros, maybe you can, maybe you can't. But isn't it also easy on GitHub? You can see this project was forked 200 times, inspired these other 20 projects. Actually, all of the data is on GitHub, isn't it? Can't we turn that into useful metrics? Or what are successful or easy metrics that we could be creating for open source? Maybe people could comment on that.
So I will, just noting the fact that we're coming up on time, I will just try to repeat, because I think they're great points. So just to reiterate the points that you made there, one is that we should actually identify and examine the conflicts that are there right now in terms of perhaps conflicting goals when you have these incentives that are being driven into the system through rankings and things like that, and agreements and policies that universities have already signed up to, like the DORA agreement, which would be leading people to go more open. But there's conflicts inherent in having both of those, caring about both of those things that we should acknowledge and name. But that the second point is that even aside from the monetary value, which may be easy to measure from a patent perspective or whatever, there is that idea that there are other metrics out there already today where people measure the impact of open source and how do we maybe raise the awareness of that. And I just want to make a call out to the fact that the CHAOSS working group that Daniel referred to and is part of as well, the Community Health Analytics for Open Source Software group has a university working group exactly examining that, and they meet every second Wednesday. So if folks are interested in that, I would definitely recommend checking that discussion out. But Tobias, did you want to bring us to a close now, because we're probably at the last few minutes?
I would maybe add something to that topic as well. Is one thing we saw as well is there's a huge difference of perception between creating own project versus contributing even actively to an existing one, even if they would be the same effort. The one gives you a lot of more blood in the community than the other one. And I think that's something we, both in research as well as for developers in general, we should encourage that working together gets some extra incentives versus creating something new just for the sake of having something on your own. because it's at the end of the day, doesn't bring us as a whole forward.
It's a great point.
So I think that's a challenge. I don't have a solution for that, but I wanted to raise that as well.
No, it's fantastic, and it's an acknowledgement that not even the open source community, I think, has this cracked in terms of what we really, what we should be measuring and celebrating to that degree. So to your point, contributions into existing projects are probably worth twice as much as a proliferation of open source projects, which will probably introduce competition issues that probably no one needs either. So yeah, it's a great point. Thank you, Tobias. Well, I'm unfortunately we're at time, so I'm going to wrap up this panel session. I want to say a huge thank you to everyone who came along today, to our fabulous speakers. Thank you, Penn, Tobias, Daniel. Thank you, Ian, for joining us on the panel. Thank you to the University of Galway for hosting us today, and for Lero, who helped make this event possible. We really, really appreciate your support. And thanks to everyone who joined us today in the room here and online, and to everyone who may be watching this in the future. We think that this is a really valuable conversation. We hope to continue it both in the context of Open Ireland Network here locally, but also in the university ecosystem. There seems to be lots of going on, so we're looking forward to engaging with those conversations as we move forward. And without further ado, I want to say have a great rest of day. And if anyone wants to find out more, we'll be sending around a follow-up email with links to some of our presentations, so folks can access those to everyone registered online, and we'll send some details about how we can continue this conversation. So, and again, thank you, Michael, for all the work done to organise this event, and to everyone who helped out there. So thanks everyone, and see you next time.